Good afternoon and welcome to Cape Canaveral Air Force Station. We're here today to discuss the upcoming Delta II Global Positioning System launch, currently scheduled for Sunday at 1:38 p.m. Delta II is the Air Force's newest expendable launch vehicle, and it will be used primarily by the Air Force to launch GPS Block II satellites. This is the first Delta II, the first GPS Block II satellite, and the first Delta launched by the Air Force since assuming program responsibility from NASA last year. I'm Lieutenant Colonel Ron Rand, the Director of Public Affairs here at the Eastern Space and Missile Center. With me today are, on my immediate left, Colonel Bob Bourne, who's the commander of the test group, the 6555th Aerospace Test Group here at the Cape. Test group is the agency which conducts all launches from the Cape here and will conduct Sunday's launch. On Colonel Bourne's left is Colonel Harry Carruthers, the Medium Launch Vehicles Program Director at Air Force Systems Command's Space Division in Los Angeles, California. And on Colonel Carruthers' left is Colonel Marty Runkle, the NAVSTAR Global Positioning System Joint Program Office Director, also from Space Division. Colonel Runkle is Sunday's Mission Director. For today's briefing, each of these three gentlemen will make a brief statement, and then we'll take questions. So without further ado, we'll start with Colonel Bourne.
Okay, as Colonel Rand mentioned, I'm the commander of the 6555th Aerospace Test Group here at the Cape, and our test group is responsible for managing the flight hardware processing and launch operations for all Department of Defense launches, both here at Cape Canaveral Air Force Station and at Kennedy Space Center on board the Space Shuttle. In that role, we are really an extension of all of the program offices at Space Division. So in essence, Colonel Runkle, Colonel Carruthers, and I all have the same chain of command. They are responsible primarily for the development and the procurement of flight hardware. I'm responsible through the test group here for processing that hardware at the launch base and launching it. The Air Force formally assumed management of the Delta program from NASA last spring. However, we had previously been involved for about a year prior to that in the modification of the two launch pads to accommodate the Delta II missile. Prior to that, we had already had the responsibility for processing the Global Positioning System satellites. At that point in time, it was anticipated that they would be launched on the Space Shuttle, so we had already modified a facility here for that processing and had some of the satellites here, in fact, in various stages of testing and storage and launch preparations. The team that's really come together for Sunday's launch includes the Air Force, the McDonnell Douglas Corporation, and Rockwell International, and I think that it's gelled extremely well in a short period of time. If you realize that the Delta program, has only been in existence for about 2 years now, an awful lot has happened in those 2 years. First, we've modified 2 launch pads for the Delta II. We've built, trained, and certified our entire launch team. We've processed the first Delta II through all of those newly modified facilities. And we've done that incidentally in parallel with the qualification test program that Colonel Carruthers has run with McDonnell Douglas Corporation on the West Coast. That's an unusual thing. It's risky in one sense from a schedule perspective to do that, and we've been able to orchestrate all of that in parallel with very few schedule hits as a result. In addition, we've tested the NAVSTAR satellites here extensively under Colonel Runkle's program direction. We've tested them here at Cape Canaveral Air Station against satellites that are already on orbit, and that's validated their performance. And we've certainly prepared the satellite that we'll launch on Sunday. We've prepared it for launch, and in addition, we've done a good bit of processing on several other satellites that are here. The launch team on Sunday will be led by Lieutenant Colonel Bob Taylor, and he'll be available following the launch for interviews. We just completed our readiness review to go into Sunday's operation just about an hour ago, and I'm happy to tell you that things are on track and looking positive for that launch. The weather is a little bit of a factor. There will be some cold fronts in the area on Sunday, and the possibility exists for some convective activity that would give us cumulus-type clouds and a small possibility of lightning. Those things have the potential of delaying the launch. We only have a 10-minute launch window, so you can see that if we have weather in the immediate area during that 10 minutes, and we would lose the opportunity on Sunday and have to slip. There's also a small concern with surface winds and upper air winds because of the cold front. All in all, we've assessed approximately a 60% chance that we will have acceptable weather conditions for launch. We're going to get back together tomorrow afternoon at about 1 o'clock and take one more look at the weather and reassess what our opportunities are. But right now it looks very good for going into the countdown and conducting the launch on Sunday. As far as the booster goes, we have only one small problem that we're still addressing. It has to do with the thrusters that separate the solid rocket motors from the first stage of the booster. There are some, these are pneumatic devices, so they have air pressure inside, gas pressure inside, and there's a pressure transducer on two of them that is acting erratically, and we're not certain exactly what the pressure is inside at this point. That is under evaluation, and we're confident that will be resolved prior to launch. There is time, should the technical team determine that it's necessary, there is time to make hardware changes that would correct that situation. So we do not believe that will be a factor on Sunday's launch. Other than that, the satellite is in excellent condition and the booster is in excellent condition. Today we're going through final stages of installing ordnance on the vehicle. Tomorrow we'll fuel the second stage, and then we'll go into the countdown on Sunday. Let me simply close my opening remarks by saying that we're very proud of our team, especially since they've had only the 2 years to draw the entire thing together, and they've done a remarkable job. I think that's a tribute to the maturity of the Delta hardware built by McDonnell Douglas. The modifications necessary to make the Delta II were able to be put in place in very short order. Rockwell International with the GPS satellite, the Space Division Program Offices, the Aerospace Corporation in support of the Space Division Program Offices and the test group here. Certainly the people in my test group deserve a good bit of credit for that. And also NASA. NASA, of course, managed the Delta program with McDonnell Douglas for a number of years. NASA has been extremely cooperative with the Air Force in transitioning the program, and I think they deserve credit also for our being able to come online so quickly.
Good afternoon, ladies and gentlemen. I feel very privileged to be here this afternoon representing the Delta II team, a team that's worked long and hard to get to where we're at today. I refer not only to the men and women of the Medium Launch Vehicle Program Office in Space Division and the test group personnel down here at Cape Canaveral, but also to the McDonnell Douglas Space Systems Company, the prime contractor for the Delta II launch vehicle, and the numerous subcontractors and lower-tier suppliers who have all played very key roles, very important roles in producing the Delta 184, which is the first of the Delta II series of launch vehicles, which is currently out on pad 17A awaiting launch on Sunday. The Delta II is the newest and most powerful of the Delta series of launch vehicles. The original Delta contract was awarded back in 1959, and the original vehicle was an offshoot of the Air Force's Thor Intermediate Range Ballistic Missile Program. The first Delta launched here at Cape Canaveral Air Force Station was on May 13, 1960, and that vehicle carried a 179-pound Echo-1 communications satellite to orbit. Since then, the Delta family of boosters has achieved a remarkably high rate of reliability. Out of the 182 total Delta II launches that we have had since 1960, 170 of them have been successes, a success rate of 93%. Out of the last 48 launches that we've had since October of 1977, 47 of those missions have been successes, for a success rate of 98% over a period of 11 years. The upgrades that have been made to the Delta II have improved its performance. The payload fairing diameter has been increased from 8 feet to 9.5 feet to accommodate larger size payloads. The first stage was extended by 12 feet to accommodate larger sized LOX tanks, liquid oxygen tanks, and fuel tanks. The solid rocket motors that we now use have a higher performance propellant. As a result, the Delta II can lift a payload of 3,190 pounds into a geosynchronous transfer orbit, which is a 14% improvement over the previous Delta mission performance. The Delta II program is part of the Space Launch Recovery Program, which was initiated after the Space Shuttle Challenger disaster in January of 1986. The policy of sole reliance upon the Space Shuttle for space launches has changed, and production lines for expendable launch vehicles were reopened to provide a means of launching a large backlog of grounded satellites.
McDonnell Douglas won an Air Force contract for 20 Delta II launches, and this contract was awarded only slightly more than 2 years ago in January of 1987. They started from a cold production base at that time and have achieved an initial launch capability in slightly more than 2 years, which we feel is pretty remarkable. This launch marks the first of many Delta II launches that are scheduled here at the Cape, and I'm personally looking forward to getting off to a good start.
As both Colonel Bourne and Colonel Carruthers has pointed out, we're only here today because of a whole lot of good work by a whole lot of good people over a couple of years, and it has all come together extremely well, and we're now on the verge of transitioning the GPS program from a developmental program into an operational system. We currently have, of the 10 satellites that were orbited since 1973, we still have 7 that are operational today. A couple of them have lived for more than 10 years. We're very proud of that fact. We're certain that the ones we're about to launch will add to that constellation and provide a capability for many years into the future. Now, with the launch that's upcoming, it will begin the new operational constellation, which over the next 3 years we'll launch one about every 60 to 90 days until we get the full 18 constellation or orbit constellation up. Now, the operational system will provide significant improvements in capability for navigation worldwide. It essentially will, as a revolution in navigation, it will change the way all of our systems, as well as many of the civilian systems, look at positioning and navigation. We will, for the first time, have a worldwide system that will provide accuracies to within 16 meters, velocities to within 1/10 of a meter, and time within 100 nanoseconds. And of course, there's virtually no military operation or military system that can't benefit by improved position and velocity as well as time information, and of course that's what the GPS system does best. As we mentioned earlier, this is quite a landmark. We are launching a new satellite with a new launch vehicle. I might also mention that we will also be controlling the launch of this satellite from our new facility, CSOC, out at Falcon Air Force Station. So we have several firsts going on. I am very proud of all of our folks in the Joint Program Office in Los Angeles for what they've been able to accomplish. We are certainly looking forward to the launch coming up on Sunday, and I wait to see it leaving Cape Canaveral.
Okay, thank you, gentlemen. We'll take questions now, but if you would, please wait for the microphone and then start off by stating your name and affiliation. Jay, you go first.
My name is Jay Barbary. I'm with NBC News. Colonel Runkle, could you take us through the launch of the NAVSTAR, its orbit, and what its mission will be?
Okay. We will launch approximately into a 100 by 11,000 mile transfer orbit with perigee at 100 miles and apogee around 11,000 miles. About 2 days later, we will then initialize that orbit in a circular orbit at roughly 11,000 miles up, and go through a series of maneuvers to allow the satellite to acquire the Earth, lock on to the Earth, and about 11 days later, physically then turn the system over to the ground station to go into its early orbit checkout modes. Within about 30 days to 45 days, we should have completed checkout, and it will become part of the operational system. The mission, of course, is to provide the most precise position, velocity, and time information that we can make available to all of our civilian and military users. Howard?
This also for Colonel Runkle. Could you detail the differences between this Block 2 satellite and the ones that are up there now, and what will happen to the Block 1s when you get this full constellation up?
We will continue to use both the Block 1 and Block 2 satellites as long as the Block 1s are available. The Block 2 satellites, of course, have improved systems in terms of trying to increase the onboard power capability. We have a couple of, or in particular, an encrypted mode that we have put on the new system to discriminate between the military and civilian applications. The design life for the system is 7.5 years versus a 5-year design life on the earlier satellites. So most of the improvements have been in terms of increased reliability and some increased capabilities.
Just to follow up on that, when will the civilian users be able to make use of this? Right away, or will it take a while?
The satellite will go into the constellation after the initial checkout, roughly 30 to 45 days, and it will be accessible just as the Block 1 satellites are. And of course, we put out the 2 data streams, and the civilian data stream should be available, as is the Block 1 data stream currently today.
Jay, you had a follow-up tonight.
Could you tell us, Colonel, just who the users are, what they will be using the system for, the civilians, and I understand all military and our allies. Could you brief us on that, please?
Okay, well, just about any military system itself or any operation that you can conceive where you could improve that operation by the use of improved location or velocity, you can apply the GPS system to it. And we're developing at the Joint Program Office a whole series of devices to allow you to incorporate this into airplanes, trucks, submarines, tanks, man packs, whatever. So the application is widespread. From a civilian viewpoint, surveyors are using GPS currently today. The railroads have incorporated GPS into the management of the location of the railroad cars, as well as the fuel management of their trains en route. Of course, eventually the civilian applications in military air transport, FAA applications, they are virtually endless.
John Glish?
Yeah, John Glish from the Orlando Sentinel. Maybe this is for Colonel Byrne. First off, I know you were shooting originally for the first Delta II launch back last fall in October. Can you just give us a wrap-up on what the delays were and what the hardware problems were on the rocket that's pushed you folks back to where you're at now? That's the first thing. And the second thing, just really kind of a housekeeping question. How much does each Delta II cost, and what's the total amount of money the Air Force has paid to McDonnell Douglas for the, I believe it's for the 20 Delta IIs that you folks have ordered?
Well, I'll defer the cost question to Colonel Carruthers. In response to your first question, there was no single big problem that we encountered. It was just the integral of all of the small tasks and the small delays in getting through the qual test programs on the West Coast and completing the facility construction. There's a lot of, when you operate at Cape Canaveral Air Force Station, you're not the only person here. And a lot of times the tests that you want to perform are not compatible with other operations that are taking place. So there's sometimes delays there, weather delays. It's been the cumulative effect of all of that that has driven it out from October until February. I guess I'd like to point out that when you stop and think about it, what are we, 4 months, 3 or 4 months late in launching the first one on an extremely ambitious schedule that we set out only 2 years ago. So I'm extremely encouraged that we're launching now and did not experience further delays.
I'd like to follow up, I guess, on the first part of that as well. The problems that we experienced, I think, are very typical of manufacturing startup. And I guess I would emphasize a remark I made earlier, in that achieving an initial launch capability after having a cold production base in just slightly more than 2 years is a pretty remarkable thing. Now, another piece of information, the original Air Force requirement stated back 2 years ago when we initially started the competition was for a launch in January, just last month. And McDonnell Douglas proposed an earlier launch, and even though we have been delayed by manufacturing startup problems, we're very close to what the original requirement was. As far as the cost problem, or the cost question, the total program cost runs in the neighborhood of $900 million for the 20-vehicle program.
Yeah, how much is one would cost?
A unit cost would be about $30 million per vehicle.
Harry?
Harry Colcom from Aviation Week, and Colonel Runkle again, mainly because you're from the University of Virginia. But, will the Constellation require the full 18 GPS satellites, or some in storage in orbit, or what is the mission kind of scenario?
Well, we will initially have when we call it fully operational, it will consist of 18 satellites plus 3 satellites in backup, because as you know, with time you have to reposition the satellites when you're thrusting to fine-tune the orbits. You have to take them out of commission, so we need some spares up there, as well as for any problems that you may have that would require you to take a satellite out of commission for any indefinite period of time. We are trying to build that certainly as rapidly as possible to the 18 plus 3. There's some discussion ongoing right now to even make that a larger constellation of 21 plus 3, and we will certainly try to do that if possible.
Howard?
Howard Benedict, AP. For Colonel Bourne, what dictates the 10-minute launch window, and how soon after liftoff will we know that the satellite is in orbit?
Well, I will defer to Colonel Runkle the definition of the launch window, because that really gets into the orbit that he's going into. But let's see, the timelines, I believe Colonel Rand will be able to provide for you if we go into the countdown, the events, and you'll hear on the net as they occur. But we will have the satellite into orbit, I'm guessing here, on the order of 12 to 15 minutes following liftoff, and on the order of a half hour, a little bit less, we should have already had the second stage, or even the AKM firing, the second stage firing, I'm sorry. So you don't have long to wait to make sure that we had a successful launch.
On the 10-minute window, we obviously are shooting for a very precise orbit. If you're going to provide that kind of accuracy, you need to have the satellites positioned as closely as you can to exactly where you want them. We are looking at ways to extend that window, and maybe in some of our later flights we'll be able to open that up just a bit. But it's a combination of our booster capability, where we want to put the orbit, and how much latitude we have in that trajectory and getting it in position.
Todd Halverson?
Todd Halverson, Florida Today, for Colonel Bourne. Colonel Bourne, we've been hearing recently that you might have had some problems with the payload fairing on the Delta II. Has that fairing passed through all its certification tests, and were there any problems in the testing? Did it fail any of the tests?
That gets back into the qual test program that Colonel Carruthers was responsible for back with McDonnell Douglas on the West Coast. That's one of the small problems that was encountered and overcome very quickly in parallel with processing the vehicle for launch. That was easily resolved by strengthening some members, and we were able to do it as we assembled the vehicle here for final flight. So it was not a major problem at all. It was easily overcome.
What exactly was the problem with the fairing?
Okay, let me defer then to Colonel Carruthers for that.
Well, I guess for a good explanation, I'd need to get one of my engineers up here. But essentially, during the qual test, they did a structural test where the fairing actually buckled the miniskirt during the test, and we had to do a redesign that was a rather simple redesign that we later tested thoroughly, and it has been checked out, and everybody is satisfied with that as a fix. And essentially, it's been installed, and we're ready to launch.
Susan Cole.
Susan Cole, WCPX-TV, Orlando. Should there be a problem with that cold front and the weather on Sunday, what's the next plan?
We will assess that again tomorrow, and Colonel Rand would be able to pass on to you what our assessment at that time is. Right now, based on our current knowledge, we think that the weather on Sunday would be acceptable for going into the countdown and in fact, for launch. And like I said, a 60% opportunity, we think that we will launch on Sunday based on weather. Should we go into the countdown and then experience weather problems and not be able to launch, we will probably delay a second attempt until Tuesday, only to give our people a rest. Should we determine tomorrow that the weather is not sufficient to begin the count on Sunday, then we would probably attempt again on Monday, assuming, and the weather is forecast, incidentally, to be better on Monday and Tuesday than it is on Sunday.
Carlton.
Carlton Bailey, freelance for this one. Follow up on the weather. NASA changed all their weather commit rules and criteria for their launches last year. Do you all go basically the same as theirs, or being the Air Force and the military, do you fudge a little one way or the other, or what should we look for in this?
No, we undertook in a cooperative effort with NASA last year, and it took us the better part of a year to go through this process very carefully. We went through a careful process and really studied launch commit criteria with respect to weather, the effects of lightning on launch vehicles, the effect of winds, clouds, and not just the vehicles, but the sensors that we use to track them as they launch. And we are consistent. We have a consistent set of criteria with NASA. There are always slight differences based on the vehicles. The wind constraints, for example, on the Delta are slightly different than those on the Titan and different from those on the Space Shuttle. But with respect to the major effects of weather on launches, we and NASA are in agreement and have the same criteria.
Dan Billow.
Dan Billow from Channel 2 in Orlando. Colonel Runkle, a little bit more, if you would, on what the satellite does. I guess it's a way for the military to keep track of its own forces. What will the entire constellation up there mean to the military? How important is having it up there? And also, I just wasn't clear on how high the final orbit would be.
Final orbit is a 11,000-mile circular orbit. Again, the information from the GPS will go into all of our inertial navigation systems, for instance. You will be able to tell every airframe, every ship, every submarine, every truck, tank, whatever, that they're within a 16-meter circle. That's altitude left and right, anywhere in the world, any time of day, any kind of weather. Any of the systems that would require, for instance, artillery for the Army, for instance, where you need to know where you are to establish a grid for the rest of your forces and everything. You will be able to, everybody, for the first time, will be able to operate from a single grid, for instance, is one application. Flying in bad weather, mid-air refueling, link up at sea, dark nights in the fog. You can effectively link up in a mid-air refueling without any voice communications. Typically, when you go out to do that, people have to turn on radars and basically light up the sky that they're there. You no longer have to do that. There are just many varied applications for this. It's a passive, totally passive system. You know where you are and what time it is and how fast you're going more accurately than you'll have ever been able to know this before.
Okay, back to John Glish.
This is probably for, I'm not sure who it would be for. It's really very simple. It's just another money question. How much for each GPS and how much for the whole shebang altogether?
Well, from the time the development started back in 1973 until we go through the entire 21-plus satellite constellation, in the year 2000, the total cost will be a neighborhood of $8 to $8.5 billion. Current production satellites are in the neighborhood of $65 million apiece.
Howard Benedict.
Howard Benedict, AP. I guess this is for Colonel Carruthers. Are all 20 of the Deltas that the Air Force has ordered, Delta IIs, earmarked for GPS? And are any of the GPS satellites still booked on the shuttle?
The answer to the first part of the question is all 20 launch vehicles are designated for GPS payloads. And I'll refer the second part of the question to Colonel Runkle.
Currently, we still have 2 satellites booked on the shuttle. We are obviously in the process of looking at the option of maybe moving all of those satellites to another launch vehicle, but we are currently still manifested with 2 satellites on the shuttle.
Back to Harry Colcom.
Colonel Bourne, could you give the basic weather launch commit criteria, such as the surface winds and the clouds cover and that sort of thing?
I'll do my best, Harry. There are many, and some of the numbers I will not recall without having the criteria right in front of me. But for most of the compass rose, the surface wind restriction is 50 knots. However, from the northwest quadrant, where the wind would tend to blow the vehicle into the umbilical tower, it is less, and it gets down into the 25 to 26 knot range in the worst case. We have restrictions on launching through cumulus-type clouds where you might find, convective activity, where you could have electrostatic discharge potential. That's particularly critical near the freezing level. So we have criteria on the thickness of clouds and the temperature of the air mass in which those clouds are located, and we have to be concerned with that. Also, with respect again to cumulus clouds, we have criteria as to how close you can fly to them within those. Not just flying through them if they are within certain temperature boundaries, but how close you can fly to them. There's certain criteria that we must avoid clouds by 5 miles, other criteria by 10 miles. And that includes the tops of the clouds, I might add. A cloud, for example, a thunderstorm type of cloud, topping out in the freezing level or above, we would have to fly over the top of that at an altitude that gave us 10 miles clearance over the top of it. Upper air winds are the other primary constraint, and that's a very complicated equation there. You can't simply look at the velocity and the direction and understand if you have passed your criteria or not. In fact, we launch a balloon, we track the balloon throughout its altitude rise up to as high as 100,000 feet, noting the wind speed and direction every 1,000 feet or so as it rises, collect that data, put it into a computer program. In the case of the Delta, that computer program is run back at Huntington Beach, and we come out with a capability ratio that tells us if we have passed our criteria or not. What you're really looking at there is wind shear. As the vehicle passes through various altitude structures, what wind shear forces are then placed on the vehicle. So it's not a simple matter of eyeballing that one.
Jay Barber, you had another question.
I have a two-parter here. First, for Colonel Runkle, could you tell us when the two NAVSTARs are to go on the shuttle, when they're scheduled to go?
Currently scheduled in 91, fiscal year 91, and the exact months I don't recall precisely, but I think it was like June and maybe towards the end of 91, fiscal year, like September.
We understand that you have quite a backlog of satellites. Could all of you tell us how many satellites been backlogged because of the Challenger blow-up, and how many you hope to get launched this year, and when do you hope to get caught back up with the new ELV program?
I can answer in terms of how many launches of expendable vehicles we're anticipating this year. We've previously announced to the press that we intend to launch 6 Titans this year. That's 2 Titan 4s, 2 Titan 34Ds, and 2 commercial Titans. Martin Marietta Corporation with their commercial program. On the Delta program from the Cape here, and all of my answers are from the Cape, there are 9 launches, I believe, of the Delta scheduled this calendar year from the Cape, plus 1 from the West Coast that will be launched by the Cape team here at COBE, Cosmic Background Experiment, which is a NASA-sponsored payload. McDonnell Douglas will do that launch for NASA on the West Coast. And I believe there's also 1 Atlas Centaur scheduled this year from the Cape, and that's with a Fleet SATCOM payload. Now, that doesn't address the total question of what's the Air Force's backlog of satellites. That's a more complicated question.
Others?
I don't know what the backlog is.
Can you tell? Well, I'm sorry, I don't have the mic. On these 16 launches, I assume that you're going to fly 1 satellite on every Delta. Is that correct?
With the GPSs, that is the limit of the, yes.
Do you have any others where you'll fly 2 or?
Not on the Delta.
Okay. On the Titans, I assume you're going to fly a couple. What do we talk, 12 satellites on the Titans, or?
Well, it varies.
10?
Of course, the Titan is capable of carrying 2 Discus satellites, for example.
But you can't give it, in other words, you can't give us a figure like, okay, on Atlas Centaur, you're talking about 1, you're talking about 10. You can't give us a figure where we could come up with, like, hope to launch 20 satellites this year in 16 flights or something of that nature?
No, I can't.
Howard Benedict?
Well, I guess I got 3 short questions here, I guess all for Colonel Runkle about the satellite. I understand you've got an atomic clock in these payloads. How accurate are those clocks?
Well, to 1 second every 300,000 years. So it's kind of interesting. I was mentioning that to a group one day, and I got the question, said, well, is he going to gain or lose a second?
Did you say 30,000 or 300?
300,000.
300. And a couple others. What type of ground equipment is needed to make use of these satellites? How big is it, and are you working on anything that's a lighter weight?
Well, we certainly are, and you all may be familiar with what we call our Slugger program, which is a handheld device in the 5 to 6 pound range that you'll be able to slip in your pants pocket and go with, and there are versions down to that size. Some of the versions that go into the ships, for instance, are in the 80 to 100 pound class, and of course with the increased size comes increased capability in terms of processing time, speed, reliability, and such. You kind of tailor the device that you use as your receiver to your need. High-performance airplanes need the 5-channel fast response systems. A man walking out in the field can afford to take minutes even to accurately locate his position and get away with a less expensive device. And we're buying a whole spectrum of different types of devices for the particular application we'll put them to.
Are these 5 or 6 pound handheld things operational now, or are they still being developed?
We actually have a contract, a solicitation underway right now to have vendors procure off the shelf or bring to us off the shelf hardware for us to qualify, and we'll have to make that determination. There are suppliers out there who I have read their brochures that say that these things exist. We've asked them to bring them in, subject them to our testing, and we'll make that determination.
What was your answer? If it would gain or lose a second?
I told him that I told him that probably he nor I would really care about that.
Over there in the second row, I don't.
Chip Zadro from the Avion News. Exactly, Colonel Rundle, exactly who will be able to use this? Americans, European allies, Russians, anybody off the street?
There will be two types of information provided down, two channels. And one channel of information with an accuracy of roughly 100 meters will be broadcast in the open for anyone, foreign, domestic, military, or civilians to use. The highly accurate 16-meter information will require encryption devices to decode, and that, of course, those devices will be controlled for defense purposes for both our service and their allies.
Todd Halverson.
Todd Halverson of Florida Today again. The complete total program cost you cited for us, does that include receiver equipment?
That's correct.
And could you break that down and tell us how much you're
It's
spending?
roughly 50-50.
Okay, thank you.
Close.
Okay, Howard, one more.
One more for Colonel Runkle. How many of these satellites do you need up in the right position for anybody, any place on Earth to get accurate information 24 hours a day?
Once we have 12 up, you will basically have what we call two-dimensional coverage. You'll have enough information that you can locate yourself if you assumed your altitude. You could locate yourself very accurately. We will need 18 before we have what we call our three-dimensional coverage. Basically, you need 4 to get the very accurate location. You need 4 satellites in view, a minimum of 4 satellites. And so it's just geometry in terms of how many you have to have up to provide that from a global perspective.
And by three-dimensional, you mean longitude, latitude, and altitude?
And altitude, that's correct.
Back to Todd again.
I understand these satellites are going to rove in like 6 groups of 4. Can you tell us where these groups will be stationed?
The orbits will have ascending nodes about 60 degrees apart. They're evenly spaced, basically, and as well as within the orbits themselves will be relatively evenly spaced. Now, they won't always start at exactly the location, but within that given orbit, they'll be evenly spaced.
If there are no more questions, that concludes our briefing. Thank you.